In this lesson, we'll be discussing limiting and excess reactants as they relate to stoichiometry. Please have your note sheet, periodic table, and calculator handy. First, let's discuss what limiting and excess reactants are. The limiting reactant is the reactant in a chemical reaction that is consumed or reacted first. The excess reactant or reactants are left over after the reaction is complete. That is, after the limiting reactant is consumed. It is important to determine which reactant is the limiting reactant because the limiting reactant will determine the amount of product that is produced in the reaction. Let's start with an easy example. In the first example, we want to know how many grams of zinc sulfide will be produced when 3.50 moles of zinc react with 4.25 moles of sulfur. Notice how we have amounts of each reactant, zinc and sulfur. One of these is going to be the limiting reactant, and one of these is going to be the excess reactant. We need to determine which is which so we can answer the question of how many grams of zinc sulfide will be produced. Set up the BCA table and substitute in the beginning mole amounts. Now we need to determine which reactant is the limiting reactant and which one is the excess reactant. Zinc and sulfur react in a 1-to-1 ratio. So zinc will be our limiting reactant. We're going to run out of it first. Now I've completed the BCA table, and you can see that we have 0 moles of zinc at the end of the reaction, 0.75 moles of sulfur, and 3.50 moles of zinc sulfide. So because we run out of zinc first, that's our limiting reactant, and sulfur is our excess reactant. And now we can answer our question. We know we have 3.50 moles of zinc sulfide produced, but we would like grams. So we're just going to convert. The molar mass of zinc sulfide is 97.48 grams, and so I end up with a mass of 341 grams produced. I rounded my answer to 3 significant figures based on the 3 significant figures of my limiting reactant. Let's look at a reaction where the reactants don't react in a 1-to-1 ratio. Here, nitrogen and hydrogen react in a 1-to-3 ratio. We also have masses to start with for each of our reactants, and would like to end with the mass of ammonia produced. So we need to convert each of our masses to moles in order to do some stoichiometry. I convert the grams to moles for each of the reactants and plug them into our BCA table. Now we have to determine which reactant is the limiting reactant. If I choose the nitrogen as the limiting reactant, it all reacts and reacts 1.35 moles of hydrogen, leaving 1.22 moles of hydrogen remaining. I then also know that the ammonia produced is 0.900 moles. That's 2 times the 0.450 moles of the nitrogen. So now I can answer the question, what mass of ammonia is produced by converting my moles to grams? 17.04 is the molar mass for the ammonia, and then that gives me 15.3 grams of ammonia produced. I rounded my answer to 3 significant figures based on the 3 significant figures of my limiting reactant. In the next problem, we have 13.3 liters of butane and 31.5 liters of oxygen gas, and would like to know the volume in liters of carbon dioxide gas produced. I'm going to plug my volumes into my BCA table, and then I have to determine which reactant is the limiting reactant. If I make the butane the limiting reactant, you can see that the oxygen ends up with a negative value. This just doesn't make sense. So the butane cannot be the limiting reactant. We cannot react more oxygen than we started with, so therefore the oxygen must be the limiting reactant. Using stoichiometry, I've determined that 19.4 liters of carbon dioxide gas is produced. There are 8.45 liters of butane left over after the reaction is complete. I would like you to try the last example on your own, and we'll go through the answer in class. This problem has molarity in it. So remember, molarity equals the number of moles of solute over the volume of the solution in liters.